yesterday, we remembered that our sequences have the form a sub k equals a1 plus m times k minus 1. So we're going to use this to help us figure out what is the 49th term of this sequence that we have. So we have -1 plus or -5, and it goes to 11. So before we can figure out what the negative or the 49th term is, we want to figure out what the rule is of this sequence to help us determine or to use it to find that 49th term. So it's going up by 6. So we know that m is going to be our 6. It's going to be plus 6. What is that a1? -1. A1 is always going to be your first term of your sequence, so it'll be -1. Okay. Now we have our rule for our sequence. If we're looking for the 49th term, how can I use this rule to figure out my 49th? I'm going to substitute 49 in for k. So this will give me, I know, the 49th term, a sub 49, that's going to be equal to -1 plus k times 49 minus 1.
I'm going -1 plus.
So once again,
Can you scroll up a little bit?
yep. Once again, when you're looking for a specific term, that k represents the term number. So the term a sub 49, that's the 49th term. So if we're solving for the 49th term, we just need to put 49 in for k. Okay. So a sub 49, this equals -1 plus 6. 49 minus 1 is 48. We will have to multiply. 6 times 48, that's the multiplication happening there when it's on the outside of the parentheses. We'll have to figure out what 6 times 48 is. What was that? 288. So -1 plus 288. What's -1 plus 288? And that will be our 49th term of our sequence.
That's easy.
So anytime you're looking for a specific term, create the rule of that sequence. Create the rule, substitute that k with your term number you're looking for, solve it, simplify it, you're good. Are we okay with this?
Yes.
So where we ended yesterday, we ended with this. We were given two terms of our sequence, A1 and A6 in this example, and we needed to figure out what the rule of that sequence was just based off of two terms. So once again, in order to figure out, we are not doing geometry.
I don't want to do geometry. Hey, you can make me do geometry.
So in order to figure out what the term or the rule, we need to figure out two things. We need to figure out A1 and M once again. Do we know what A1 is? What's A1? -5. But I don't know what that K is just yet. So that's what I'm looking for. Okay. So we have to think. What does M represent again? The slope. How did we solve for slope in the past? Coordinates. We have an x and a y coordinate. We would do y2 minus y1 divided by x2 minus x1. We'd solve that having reverse slope. We don't have coordinates though. We have terms. Can we turn those into coordinates though? So what would A1 equals -5 be? 1, -5. My term number will be my x. What my term equals is my y. So this would be 655. take a moment, see if you can use these two coordinates to find the slope. Do your y2 minus y1 over x2 minus x1, and see if you can find what the m would be for this problem. So, using our slope formula, we should have had 55 minus negative 5 over 6 minus 1, which should have given us 60 over 5, which equals 12. We now have our m and our a1, so we can rewrite our rule. A sub k equals a1. What was a1 in our problem? Negative 5. That very first term, we were told a1 equals negative 5. Then plus our slope, which we know is 12. Then k minus 1. So this is our rule. So we can find the rule using two coordinates, right? Assuming one of those coordinates is a1. What if we're given two coordinates and one of them isn't a1 now?
You don't get A1.
All right, let's focus. So, we now are told two random coordinates, two random points along our sequence. We have A10 equals 36, A sub 18 equaling 12. We need to try to figure out what that rule is. We don't know what A1 is. We were given it in the last one, but we don't know on this one.
We have to figure it out.
We do have to figure it out to be able to get the rule. Can we figure out our slope though?
Oh, yeah.
So once again, our slope, we just need two coordinates for the slope. What would my first coordinate be? 1036. And my second coordinate? 1812. So then we can put this into our thing, y2 minus y1 over x2 minus x1. 12 minus 36, that's going to be negative 24, good. 18 minus 10, negative 24 divided by 8, negative 3. So this is my slope of my sequence. So far I have a sub k equaling a1, which I don't know, plus my slope of negative 3, so I'm going to put that minus 3, times k minus 1. I need to figure out what a1 is. Okay.
Just plus 36. 10 times.
So I could start with 36. I could think, okay, this is the 10th term, and I could go backwards 9 times until I end up at A1, but that's going to be a long time. What if I started with A sub 2,436?
Oh, that's a lot.
That would be a lot. There has to be a quicker way. So what we talked about last week, we were solving for that y-intercept. In order to solve for that y-intercept, we had to get rid of that x and our y. We couldn't have those other variables in there. So what other variables do we have in order that we need to get rid of in order to solve for a sub 1? We need to get rid of that k, and we need to get rid of that other a sub k. So if I can put things in to replace these, then I can solve for my a sub 1. I'm going to rewrite this a little bit lower so I have some space. So I have a sub k equaling a1 minus 3 times k minus 1. Now here's the thing though. How do I know what to put in for my k and what to put in for my a sub k? What did we do last week when we were solving for a y-intercept? We used our smallest coordinate or our smallest points. So which one do you want to use? A10, 18 and 12? Okay. So a sub 18, this is going to be, or 12 is going to be my a sub k. I'm told a of 18 equals 12. I'm looking for a sub 1. It's minus 3. If I put 12 in for my a sub 18, or my a sub k, that makes k 18. So k is like your x, the number is like your y in this case, just like last week. From here, now we just need to solve just like what we did last week in order to figure out what that a sub 1 is. Just like solving for your y intercept. 18 minus 1 is 17, so we have 17 times negative 3. 12. 17 times negative 3. What's 17 times negative 3? Good. Okay. What can I do to get a sub 1 by itself? I need to move that negative 51 over. So if it's a negative 51, I can add 51. I'll cancel this out, but I have to do both sides. So 12 plus 51 gives me, what is that? 63 equals 80 sub 1. I now have a sub 1. I have my m, so I can rewrite my whole sequence with the full rule of a sub k equaling 63 minus 3 times k. So really, we're doing the same process we did last week. That same thing where we had to solve for our b, solve for that y-intercept. We're doing that same thing on this process. The only thing that's different is we're changing it to, rather than having y equals m supposed to be, we're using the sequence rule. But it's the same steps, same idea. Find your slope, plug that in, figure out what numbers you can substitute in for k and a sub k, and then solve for that a sub 1. Are we okay with this? So it's the same skills we learned last week, we're just applying them in a different way. Alright, so we have two numbers, a sub k, or a sub 6 equals 7, and a sub 14 equals 11. See if you can figure out your slope, substitute in some numbers, and then input. Okay, let's talk about this before we get out of here. We have plenty of time. Alright, so what do we find our slope to be?
1/2.
1/2. We use the coordinates 6, 7, and 14, 11. So knowing this is 1/2, we could rewrite our rule as a sub k equals a sub 1 plus 1/2 times k minus 1. In order to solve for a sub 1, we need to put a number in for a sub k and k. We can't have these other variables in here. So we can use either of these 2 points. I'm going to use the smaller one, so I'm going to put 6 in for my k and 7 in for my a sub k. Six times 1, or 6 minus 1, that's 5. 5 times point, or 5 times 1/2. Half of 5 is 2.5. If I turn it into a decimal, solve for your a sub 1 as your final answer.